Justifications for these. Okay, so our first one we have f of x is concave up at x equal to 3. Come on, I just oriented it. Alright, while we wait for this, which derivative are we using for concavity? Second derivative. Good. So we're going to be looking at our second derivative here. Make sure you name it by name. Don't say the second derivative or the function. Make sure you name it. So since f double prime of x is greater than 0 at x equals 3, or you could say at that point. All right, 2, f of x is increasing at x equal to 4. Since what? Which function? F greater than 0 x is greater than 0 at x equal to 4, or at that point. Good. All right, 3, g of x has a relative max with the x equal to -2. The relative max, we have positive to negative. Make sure you are claiming that it's g that we're working with, not f here. So this will be since g prime of x changes from positive to negative at x equal to -2. Okay, do you have questions on the first 3? So number 4, h prime of x has a relative min at x equal to 4. So relative min, negative positive. Make sure you are using the proper function here. So if h prime has my relative min, which function am I using for my justification? Good. The derivative of that, which is h double prime of x, has a relative. Since h double prime of x changes signs, or changes from negative to positive at x equal to 4. Good. All right. Number 5, h of x is concave down. Since h double prime of x is less than 0 on the interval -2 to 5. All right. Do we have questions on 4 or 5? Show me the thumbs. How are we doing so far? Yay! I'm so glad. All right, f prime of x is decreasing on the interval 5 to 7. All right, which function am I using for my justification here? Good. Again, f double prime is negative or less than 0 on that interval. G of x has a point of inflection. It's been a while since we've done that. What's my justification for that? Good. Since second derivative, so g double prime of x changes signs at x equals -3 and 5. And then our last one. Ooh, the particle is speeding up at t equal to 8 seconds. What's my justification for speeding up? Good, our same side. And so you could say since b of 8 and a of 8, or you could just say since b of t and a of t are same sign at t equal to 8, I want to say. So I'm going to just put it together since b of 8 and a of 8 have the same signs. Okay. Questions with any of these justifications? Are there any other statements you can think of that you're not certain what our justification would be that we did not cover here? Critical points. What would be my justification for critical points? So we just need that our derivative equals 0 or undefined. I think that's the only thing that wasn't up here. Point of inflection, we have to actually change signs. A potential point of inflection is where just the second equals 0. But I think these are all the justifications. Okay. So today for our free response, go ahead and get your free response packet. Let me pull it up here.
Well, it's not in class.
All right, so again, this is what we're looking at in terms of pacing. So last class we did free response with grade and grade out, and we did some more with our multiple choice topic 2. Last night we did multiple choice topic 3. Today we'll go over questions on that, and we're going to do free response with function analysis charts. And so our function analysis is a lot of the justification stuff. Now they also like to throw other things in here, looking at our more recent free responses. For function analysis, they were asking some stuff about related rates. There's something else sneaky that they're asking about. Oh, they threw in like a cross-section in here as well. So we're going to be taking a look at a couple of these in just a moment. And your homework tonight, so I don't forget to say it this time, is multiple choice topic 4. So in your multiple choice packet, you're going to be doing topic 4, which I think is on interviews. So that's your homework for next class. Okay, so let's turn in our free response questions to the function analysis charts question. Pull that up here. Okay, so I'm going to have you do 2 of these. Again, we'll take 30 minutes. We'll get like we did last time, set a timer for 30 minutes. You'll see what you can do in those 30 minutes and we'll grade it. Before we do this, I want to just kind of take a look at the types of things that they're asking on these questions, because I feel like they're bringing a lot of different topics for these particular questions. So our first one in 2018, again, you can see there's a chart. This is talking about our height of a tree. In part A, they ask you to estimate H prime. B, they ask you why there must be a time that the derivative equals a certain value. C, Riemann sum. That's a common type of thing that they make you do with charts. And then D, they ask for the rate of change of something here. So that, I feel like, is kind of a newer thing that they're introducing to our topics. Let's go take a look at 2017. So again, a chart, and we have a, let's see, this is the area of the horizontal cross-section of height of a tank. So again, we have a Riemann sum, and they ask us about overestimating or underestimating. And then part C, they give us a function to represent the area of our cross-section, and they ask us to find the volume. So they did for our volume, they used to, years ago, they used to have a separate free response question that was often your area between the 2 curves, volume using rotations, and volume using the cross-section. It seems like in more recent years they've kind of snuck that into other parts of our questions. And so here we see our cross-section volume shows up within our function analysis chart, so just be aware of that. And then D, they're asking us about, I think, rate of change something again. The rate at which the volume of water is changing. Okay, so 2017, 2018, I think those are, I feel like, a little different than previous years. So I want to take a look at 2016 here. So here, they don't actually ask us anything about Riemann sum. They don't ask us anything about like our derivative explained in the mean context. This is really just a chart of values. So it's not, as in GeoGuessr, they don't tell us what it represents. It's just a chart of values. So here they're asking really just a couple of different derivatives, and then they're asking here. So I feel like this is kind of a, I don't know, this might be an other question, but the fact that there's a chart, I kept it in the function analysis chart as part. This could technically be another question. All right, and then in 2015, this is another typical type of function analysis chart. Here's a chart of values. This is velocity for Johanna. And they ask us to estimate, again, the derivative. So that's a common thing we see. They ask us to estimate the derivative value. And then once again, a trappist or a Riemann sum. This one was a right Riemann sum. And then here they bring in somebody else. So Bob then with his velocity and information about that. So for us, we are going to do, I'm going to go with question, I believe believe I want question 2017. And 2015. So we're going to do 2017 and 2015. 2015 here you can see is no calculator. And then 2017 I think was also. Oh, 2017 was a calculator. Okay, so 2017 is a calculator one. So you are going to get out your calculator for that one. Now, obviously, for the actual AP test, they make you put away your calculator if you need to. For my other calculator, use that calculator. I know, I just really put that one. Is anyone else use calculator? I was thinking you would. Okay, so again, normally they'd be like, you can't have your calculator on the non-calculator section, but I want you to kind of have those 30 minutes to distribute between the questions as you want. So just make sure that if you are working on question 2017, that you have your calculator, you may use it for that. For 2015, you should not be using the calculator. So let's go and take 30 minutes. I'll put the timer on up here, see what you can do. I'll check in again around like 25, see if everyone's just twiddling their thumbs, and we'll go ahead and pause and see. All right, so again, 2015, 2017. 15 and 17. For those of us that are done and are just waiting for something to do, the next thing I'm going to have you do is on 2018. Alright. On 2018, I Okay, for those that are wanting to move on to the next thing, I want you to, on 2018, take a look at part A. How would you find, or how would you estimate h prime of 6? And I know, I'm saying that for those that want to move on to the next thing. And then for B, how would you go about that guy? That's what we'll be doing after we go over our FRQ response. So those that are looking for something to do, that's what we'll do next. I'll take a look at that.
Yeah, the accent is no way to explain it, but it is
What are you saying back there?
I definitely had a miss bar graph.
What's that mean?
No, I'm trying to remember.
Like, that was her name?
Yeah. No, that's not like it. My fifth grade teacher named Miss Margraf.
Was it 2 F's or 1?
Garrett, this is very important. I don't know any other Margraphs with 2 F's in this area.
Well, she had blonde hair. She was only there for the first couple of months. No, she was a substitute teacher. Yeah. This Candela, she was a witch. But then she went to Arizona or something for a long time.
Are you sure it was Margraph?
Oh, burger.
See, you got my hopes up. I know a Birdgraph, but I want the Margraph.
Smart.
That is close.
Thank you.
No longer. I only like to play.
And then this one's so weird.
Okay, let's go ahead and take a look at our grading for this. What'd you guys think? 2017 or 2015? Which one did you like better? I like 15 better as well. I know. Okay, so 2015 I feel like is what I would have guessed as this is what they used to have our function analysis type questions were typically along these lines where they'd ask you to or estimate approximately that guy. They would ask you something about maybe total distance, maybe not. So this is kind of a particle motion mixed in with their function analysis, but I feel like this is what they used to be like. And when you take a look at 2018 and 2017, you can see it's asking a little bit of different information where they're asking us about related rates and about volume using a cross-section. So just a heads up, they might be doing that again this year. Okay, so let's take a look at 2017 first. Also, in case you guys were wondering, this was the timer. That's to the end. The dinosaur won. Okay.
Remember you did the turkey one?
Woo! I do remember the turkey one. Okay. Alright, so 2017. 2017, we're working with the tank here. Now, it took me a minute to kind of figure out what in the world they were talking about. But we have a tank with a height of 10 feet, and then they tell us the area of the horizontal cross-section is modeled by that. So we don't know what our tank looks like. Who knows? Some type of wonky tank here. But we know that our height is 10 feet. And I said we don't know what the tank looks like, so I just made it weird here. Maybe it's been rusted on the sides. And it says the area of the horizontal cross-sections. If I were to do horizontal cross-sections, if I were to like chunk out this right here, the area of that is modeled by A of H. Okay, so they're taking horizontal cross-sections, and they're telling you the area at that point. So if I was at height 0, how much area do I have? 0. If I was at height 2, how much area do I have? 14. Sorry, my area was 50.3 at height 0. So this is the idea of what's happening. We're taking horizontal cross-sections, and that's what this chart is telling us. Okay, so A was just using the left Riemann sum to approximate the volume of the tank. So we would be integrating our volume. It's always integrating the area of the cross-section. Well, our cross-section, they didn't tell us the shape because it's changing probably. So our area of the cross-section, they said, was A of H. So we're just integrating A of H. And we're going from 2017, right? Am I looking at the wrong one?
No, you're fine. I
Okay.
just thought you were going in order of A, B, C.
I am.
Oh, yeah, okay, I just keep following.
That's okay, because part C did ask you to find the volume as well, so that's maybe what you were thinking.
I have a question.
Yes.
How do we know that the volume is the integral of the cross-section over? What?
So in general, our volume is the integral of the area of the cross-section, and then we had our shortcuts.
I don't even remember that.
No,
Like that was our project that we did.
Literally just have the area, the area, the area, and the shape of the cross section. Like,
So we have shortcuts when the shape is an equilateral triangle. We know our area is root 3 over 4 sides of our area.
that's the kind of thing we're talking about?
Yeah.
Oh.
It's just, here we don't have a specific shape, they just told us the formula for area of the cross section is A of H. Okay. Alright, so the question is, what are our bounds? Well, we're going from height 0 to height 10, so that's what we're looking at here. Alright, so I'm just going to kind of talk through each piece and then we'll look at our framework. So then B, it says, is over or underestimate, so you have to think in terms of, is our function increasing, decreasing? We'll take a look at that in a moment. Alright, so C, they say the area of the horizontal cross-section is modeled by this function here. So instead of them just giving us individual values, they now give us a function that models that. So it says find the volume of the tank. So again, we are integrating, now we have an actual function for this. So we're integrating f of h dh, and again, we're going from 0 to 10. All right, and then part D, it says water is pumped into the tank. So when the height of water is 5, so when h is 5, the height is increasing at a rate of 0.26. So my rate of change of height, so the h dt, is increasing, so a positive 0.26 feet per minute. And then it says using the model from part C, so we're using our function here, find the rate at which the volume of water is changing. So we want to find dV dt when the height of water is 5. So we want dV dt when h equals 5. Okay, so that's what we're trying to do for each of these components. So let's go and take a look at our framework. So part A, you got a point. Why does my board mess with me? Okay, for part A, you got a point for your left Riemann sum. So we have, again, we're integrating from 0 to 10 of A of H. So just basically 1 point for your setup here. So you should have had 2 times 50.3 plus 3 times 14.4 plus 5 times 6.5. And then 1 point for your actual answer. Remember, you don't have to actually simplify. So if you simplified 1 times 76.3, but this is kind of a 2 point here. So 1 point for doing left, so kind of the 2, 3, 4, 5. And then 1 point for the actual numbers there. Notice that there is a point for having your units in part A, part C, and part D. So check, did you use your units for A, C, and D? If so, you get that point. If you missed your units in any of those parts, you lose that point. Notice too that, now you work. Keeping my cool. Notice that it tells you to use units of measure. So specifically when they tell you must use it, they will be points assigned to order. Did you have a question, Kerry?
Can you just flip back? I might have missed a small something. No, you're fine. Don't worry about me.
Now I don't know what I'm looking at. Okay. So A is just a Riemann sum. Now B, it said, was it? Are you good?
Yeah, no, we're good.
Okay. So B is asking is an over or underestimate. So they didn't tell us the function itself, but they did tell us that the function was decreasing. And so when we have a function that's decreasing, we did a left Riemann sum. So if you want to think of your left, when our function is decreasing, then it's going to be an overestimate. So it's not that we knew what the function looked like, but they gave us the information that was decreasing. So it's an overestimate because it's a left Riemann and our function is decreasing. So 1 point for your overestimate would be your reason. Okay, do we have questions that you're being?
Would you draw that to explain your answer?
You can draw it for yourself, but this is not sufficient to explain. You would need to say because it's a left Riemann and your function is decreasing. Is what they want. Okay, and then part C was just straight up, again, volume equals the integral of your area of your cross-section. And so this specific one, they gave us our area was f of h, so you're integrating from 0 to 10 of f of h dh. So that one in your calculator, you should have gotten 101.325. So 1 point for your integral setup and 1 point for your answer. Make sure your integral has limits and dh. right, and then our last one. So it asks us to find the rate of change. We want to find dVdt when h equals 5. Now our volume, it said based upon our model in C. So we said our volume in C is equal to the integral of f h dh. So this tells us our volume only at the, like for the entire tank at height 10. So if I were to do it in general, then my volume is going to be the integral from 0 to whatever height we're looking at. And I know it's f of h, but when you use that h as your variable, they just have you change it so that you should just say f of x dx. You kind of get to choose your variable there. X is usually what we use. X has already been taken for this, and usually t is to be used there. So our volume is represented as the integral of our area per cross section. So we go to do dV dt. We're doing fundamental theorem of calculus here. We have the variable, so we take h, plug it in, so it'd be f of h, times our derivative of that value, so it'd be h dt. And then when we take 0, put in, be f of 0 times 0, which is just 0. So our derivative of our volume is just really f of h times dh dt. Now the reason why we had to do that dh dt is because we're taking the derivative with respect to time, and f of h is not a model of time. It is a model based on our height. So now we want dV dt when h equals 5. So we're going to find dV dt specifically when h equals 5. So we would do it, h is 5. And then my dH dt, they told us that our height is increasing rate of 0.26. So they just times 0.26. And then that's what you're punching to your calculator. So that's what they're doing here. Let me see if now it'll let me zoom in. Okay. So that's what they're doing here. They're just in their chain rule. They're saying it's our change in volume with respect to height, and then our change in height with respect to time. I haven't just did a fundamental theorem, so let's go with that there. And you get 1.694. So the volume water is changing at the rate. So we had 2 points for finding dV dt. My guess that most likely they would do 1 point for the f of h, 1 point for having your dH dt, and then 1 point for your answer. 1.6. Okay. So again, 3 points for D, 2 points for C, 1 for your integral, 1 for your answer, 1 point for B, and 2 points for A, 1 for your left remote sum, 1 point for your answer, and then there's that 1 point overall for your units. So then total of your score put at the top. Yes.
For B, you can't use the second derivative, right? You have to like just figure out the left and then.
Yeah, because we don't have any information about our second derivative. There's no function for us to take the derivative of to know whether it's concave up or concave down. So we just operate upon the fact that it's decreasing, so it's going to be going down, and then a left remote sum will be going out of that.
So that's concave up.
Probably. I mean, it could be concave down and decreasing still, right? Like, let's say it was just that portion of it. We're concave down, but we're still decreasing. So guys, for your Riemann sum to know if it's an over and under estimate, you don't need to know concavity, you just need to know increasing versus decreasing. All right, do we have questions about any chunk of this in terms of grading or the content itself? Okay. Yes.
Can you go over how to take the Riemann sum?
Yeah. So we're doing, what was it, a left Riemann sum. Let me bring it back to here. Okay, so my left Riemann sum, I'm looking on my graph, we've got 0, we've got 2, we've got 5, we've got 10. So I want my left Riemann sum to be at the height at 0, at height 2, and at height 5. So I'm doing this guy. Okay, so I'm using left, left, left. Okay, so my so it's going to be that width times my height. So my width of the first one is 2 times my height, which is 50.3. And my next width was 3 times its height, and again we're using the left height. and then my width, which is 5, the height, again, the left height. Does that make sense? Let's make sure you actually only have 3 in the end. And again, I'm using the left heights. Other questions with this free response? Okay. Let's go and take a look at our other free response, actually the nicer of the two. Alright, so here we had Johanna jogging, and then I think Bob came along riding his bike. Because Johanna's so fast, he has to ride his bike to keep up with her. This is Abla jogging. She is fast. Okay, so part A says to estimate the value of v prime of 16. Whenever they ask you to estimate or approximate a derivative, and we're given a chart, then they want you to, so basically look at where 16 is. 16 would fall within here. We're going to use the stuff immediately to the left, to the right of it. So we're just doing our slope based upon those values there. Okay, so we have 240 minus 200 over 20 minus 12. So our approximation is 5. Did they say something about units? No necessary for units here. So 5 is your answer for A. Again, whenever it's that approximation, they're looking for the algebra 1 slope. Just go as close around the value as you can. All right, B, it says, explain the meaning of that integral absolute value of v of t in the context of this prompt. Remember, integrating our absolute value of velocity is total distance. And then approximate that using right Riemann sums. So when we do a Riemann sums, we're going to be using the right sides for our heights. All right, so we've got 1 point for your explanation. And our explanation is it's the total distance that Johanna jogs over the interval from 0 to 40. They want you to not just say total distance, but what time frame we're looking at. So you do want that component of 0 to 40 minutes. And then 1 point for your right Riemann sum and 1 point for your approximation. So you'd have 12, let me zoom in again. So 12 times 200, 8 times 240, 4 times 220, 16 times 150. And that simplifies down to 7,600. So 1 point for total distance over the time, 0 to 40. 1 point for right Riemann sum, 1 point for you. All right, do we have questions on A or B? Yes, Justin.
So when you're like trying to find speed, what is that? Like in terms of like the absolute value of it?
So it's just absolute value of velocity, it's not the integral of it. So you just do absolute value, let's say we want the speed at type 5, absolute value is v of 5.
Miss Margot?
Yes.
Do you like get standing up?
No, so you can stop right here and you're done. All right, and then Bob came along riding his bike. And they gave us his velocity as v of t here, and then they simply just asked you to find his acceleration. This one was our non-cactive, right? Yeah, non-cactive, this one. So you're just doing your derivative. So you got 1 point for using your derivative. All right, so first you have to find your derivative, b prime of t. Make sure you label it b prime of t equals 3t squared minus 12t. And then 1 point for actually using it, so just take 5, plug it in. Again, you don't have to simplify. You can just have 3 times 25 minus 12 times 5. But your simplified answer would be 15. So 1 point for using your derivative, 1 point for your answer. So it's kind of 2 points right here. Make sure you label. Do not say b prime of t equals 3t squared minus 12t equals times 5 squared minus 12 times 5. You do this, you lose points. It's called a linkage error because this does not equal that. You're saying that the velocity or the acceleration, the derivative or velocity, equals 15 at all times. So do not make that linkage error. They don't like it. I don't like it. Nobody likes it. Redefine this. This is my v prime of 5. Relabel what it is that you're finding. Okay, and then the last one was to find your average velocity for Bob. Good old Bob. All right, and so average velocity, remember when we're doing our average, we want to think back. Our average velocity would be change in position over change in time. Now they didn't give us our position function, did they? But what could we do with that to find our position function? We could integrate it. Good. Also, too, we have okay. So we're looking at the interval 0 to 10. All right. So here's our integrating. We're over the interval 0 to 10, so 1 over 10 minus 0. Think back to also when we asked for average value of a function. Remember that was 1 over b minus a times the integral of our function. So that's what we have here. So you can either think of it as integrating to get our position, or you can think of your average value. So it's 1 over 10 is our 1 over b minus a, and then we're integrating our velocity. That's what gets your position. So either way there. So you have 1 point for your integral. Again, you have to have the 0 to 10 and your dt. We have that 1 over 10 in front. And then 1 point for our antiderivative, and then 1 point for your answer. Again, you don't have to simplify down to 350. You could have stopped right there. Here, they did not explicitly ask for units, so you'll notice no points are contributed to having your units. But when they specifically ask for it, guaranteed there's going to be a point contributed to it somewhere. Sometimes it's for all of them, sometimes it's just for a part of it. Okay, so 3 points in D, 2 for C, 3 for B, and 1 for A. Do we have questions on C or D? Yes.
When they ask like based on 5 Bob's average velocity, how do you know when you're not when you don't have to give them the actual number? Do you never have to give them a number?
So your free response, you only have to simplify down to no complex fractions and no trig should be remaining in your answer. Once you've evaluated trig and you take care of complex fractions, stop.
So
Don't waste your time and don't make a mistake.
So if it was like 10 times sine of 30, you have to simplify that?
Yes, you have to simplify sine of 30, but you could leave it as 10 times. What is sine of 30? What? Okay. So you can do it as 10 times 1/2.
What about the first line, average velocity? Do you just leave it like that?
No, because you have to evaluate your integral. So what they define as is basically arithmetic in the end. So you don't have to simplify arithmetic. So adding, subtracting, multiplying, dividing. But like natural log of 2, you're not going to know what natural log of 2 is without your calculator, so that would be a lot of mistake. But sine of 30, you do know sine of 30 without your calculator. So you calculate that. Yes.
Test will be free response write an equation that would solve to do that or something? Like, do you have to, like, the second part that you wrote there, can you leave it that, or do you have to put in a number?
So if it says to write, so oftentimes it'll say set up but do not solve the integral, yada yada. So you literally just set it up and you don't solve anything.
So you don't, like, where do you solve for that? Like, you don't have to integrate it?
Yep. Yep, if it just says write but do not solve, then you literally just set up your integral and you're done.
But if you kept going, would it?
As long as you don't make a mistake, it would be fine. But once you start to write incorrect information, you will lose points.
Even if you just have the equation there?
What's that?
Even if you have the...
Yeah. So like, say you had this correct, but then you answered it wrong, had 450, you lose your point for the answer. And that's why it's really important. It goes against everything within me as a teacher. But I don't want you to simplify it on your AP exam, mock exam, or the actual AP exam. Stop here. Do not go further, because so many times students will lose a point or more because they simplify incorrectly. If you have this correct, but your final answer is wrong, they look at whatever your final answer is. So they have to keep looking at whatever information is there. Also, let's say you completely botched this up for some reason, you're integrating your acceleration. Don't take the time to erase it, put a big X through it. Anything that's crossed out is not graded. So just put a big X through it and start back over on the other side. Okay, questions with that? Awesome. So I'm curious, show me with thumbs, how did we do with 2017? Okay, now switch it to 2015. Okay, good. So 2015 is again the more common type of problem they used to do. 2017, 2018, as you can see, are a little different. So definitely wait for another. Okay, real quick, look in your packet at 2016. So 2016, for part A, what do we have to do to find our derivative k prime of x? Chain rule. So chain rule. I think we even did this one. Chain rule, derivative of the outside to inside stays the same times the derivative of the inside. Okay, for part B, what do we have to do to find our derivative? Quotient rule. Some of us are struggling with quotient rule. It is not just simply g prime divided by f prime.
Divided by
Yeah, we have to do f of x times g prime. So second stays times derivative of the first minus, I'm supposed to adding still. First stays times derivative of the second all over the bottom, and make sure you slap a big old huge set of parentheses around their brackets. That is our derivative of quotient. I like this one. Alright, and then see, it says to evaluate this, we don't have a function, so I can't do my antiderivative. But what's the function before my second derivative? F prime of x. Now, because there's something other than x here, we technically have to do a little mini u sub. So we'd have let u equal 2x, du equals 2 dx. So I would have to do then 1/2 du equals dx. So you do need to do a little mini u sub where you would change your bounds. You have to deal with that 1/2. When you do your antiderivative, though, we know it's going to be f prime. It's just you have to do that little mini u sub with it. Okay. And then I want you to look up at 2018.
Okay, I have a question. On the test, how much, like, is it gonna look like this? We're gonna more space.
Oh, yes. So they give you all kinds of space. So multiple choice questions, there's usually like 2 questions on a page. For response, they give you like half a page for each part. It is a big time waster paper.
Is it like the room that you have on all the other FRQs?
And they're like, what?
Same amount of room you have for other FRQs?
I mean, you've got like half a page for part A, half a page for part B.
Today is the last day of junior post-secondary presentations. Teachers, please do not mark these junior students absent. Jolly juniors, please see your counselor in the following location during Stinger 5. Miss Anderson,
What's the whole
last name,
What did I say, 4?
through DEK.
So in your
Library.
packet.
Miss X, last name PR through SN in the front of the cafeteria. Miss Johnson, last names FO through Z in the cafeteria front. And Miss Portier, formerly Miss Roseberg, last names GRI through KO in the back of the cafeteria. Thank you.
I'm adding one more component to your homework. So your homework is out for multiple choice. And then on your 2018 question from today, I want you to do just part B. 2018. FRQ number 4. Part B. Also, I wrote out the work to our questions over here. I'll scan them, put it on Blackboard so you guys can see that, and then we'll go over them next class.